Okay, this video is for Monday and Tuesday, September, 27th and 28th. We went over, started talking about dilations. Okay, you should have watched a couple of slideshow videos yesterday. And today I'm going over the handout. So, dilations, if I look at these two figures, which is my pre-image? Can you tell? This is my pre-image because it just has A, B, C, and D. I'm going to highlight it red. Okay, so this is my pre-image. My original. I know that because this has my little prime marks on it. So this is my, darn, this is going to bleed through. Oh well. All right, this is my image. Yep. My scale factor is 3. This is how much I'm enlarging my image. This is 3 times as big as this. Okay, so if I find, we'll look at it on the next page. So this is 3 times as big as that. How we know is I take my X and I take my Y and I multiply by the scale factor. So if A is -1, 2, I would do -1 times 3, 2 times 3. So that would be -1 times 3 will be -3. 2 times 3 is 6. So my A prime should be -3 sorry, that's 1. Should be 3, 3. -3, -3. All right. So a dilation creates a shape. Creates a shape. A dilation creates a figure that is the same shape, but a different size. This is known as similar. Remember, if they're the same shape and same size, they're congruent. Okay, that's equal. They're the same. Like our identical twins. But once we change the size, they become fraternal twins. They're only similar. Scale factor is what we use to make the enlargement, which makes it bigger, or the reduction, which makes it smaller. If our scale factor is bigger than 1, we're making it bigger. If my scale factor is smaller than 1, we're going smaller. Some characteristics of dilations. Orientation is the same. Okay, if I have an M, okay, and I translate it and I go down and to the right, it still looks like an M. If I reflect an M, it looks like a W. If I rotate an M, it looks like a 3. Okay? But when I slide, the orientation stays the same. It's facing, it doesn't turn or flip. Same with my dilation. It's going to be in the same place. If my dilation looks like this, that means I dilated and then turned it. That's 2, that's a series. Okay? So orientation's the same. It stays the same, just like a translation. I'll put just like a translation. But congruence is gone. Okay? Once I change the shape, if I have an M and I rotate it, flip it, rotate it again, these are still all congruent. They're the same size and shape. But once I take out the size, once I dilate it, it's only the same shape, so it's only similar. Congruence is gone, and I only have similarity. Okay, the pre-image is the first. That's where we start. Image is the second. All right, let's go back to this one. So the first thing we have to do is label our shape. Okay, and that's important. You gotta label it to know what the quadrants are. So A would be -2, 3. B would be 2, 1. C would be 1, -2. It's important to make sure you put those negatives. Now our scale factor is 2, so we learn from over here, we're just gonna multiply our x and y by our scale factor. So I'll do 2 times -2, that gives me -4. You gotta keep the negative. When you go negative times a positive, your answer is always negative. If you go negative times a negative, then you get a positive. So negative times a positive gives you a negative. 3 times 2, that's positive and positive is a 6. 2 times 2 is 4. 2 times 1 is 2. 2 times 1 is 2. Here's another negative. -2, that's going to be -4. All I do is plot these points. A is -4. Here's our 0. 1, 2, 3, 4, and 6. There's A prime. Make sure you label. B is going to be 4, 2. 4, 2, B prime. C is 2, -4. So 2, -4. Now one thing we're going to start doing when we draw or connect our dots, we want to start using a ruler so we can be even more precise. What's really important in math is neatness, and we haven't really been worrying about it so much, but now we're going to try to be as precise as possible. We're going to line up our dots, our points, and we're going to just connect. Okay, and I want to line it up right in that center. Okay. Line it up. Now we have our dilation. We can do the same thing here. I'm going to label A, B, C. A is -4, 6. Make sure you see that's a 6, that's your 8. Kind of looks the same. B is going to be 4, 4. C, oh, it doesn't go, it stays on Y, so that's 0. And we go down 4, -4. Now, this time we're going to be multiplying our scale factor by 1, it's 1/2. So we're going to do -4 times 1/2. Okay, before we can multiply a whole number, we need to turn it into a fraction. So all we have to do that is put it over 1. Then -4 times 1 is -4. 1 times 2 is 2. Okay, let's simplify. 2 will go into 4 2 times, so this equals -2. So -4 equals -2. Because it's a half, I hope you can see that really all we have to do is take a half of those because they're all even. So half of -4 is -2. Make sure you keep that negative. Half of 6 is 3. Half of 4 and 4 is 2 and 2. Now let's think about 0. We can't take half of 0, but what we're really doing is doing 4, or each quadrant by multiplying by half. If you multiply anything by 0, what do you get? 0. So that's going to stay 0. -4, half of that is -2, not positive. Now we just take it. -2, 3 is going to be right here. That's our A prime. 2, 2. 2, 2 is our B prime. 0, 3. Remember, 0 is our X, so we don't go side to side. We stay on 0 and go down 2. Okay, we're going to take our ruler, make nice, clean lines. Okay, I'm pushing kind of against the ruler to make it nice and straight. And now that is our smaller image because we had a scale factor less than 1. Okay, that's what we're doing. And we finished this today, and then we worked in the book. So the next video will be the bookwork.